Okay, so in this video, we're going to be talking about speed, velocity, and acceleration as part of our motion unit. Speed is the rate of change in distance over time. Speed, because it's the rate of change in distance over time, both of which are scalar quantities, is scalar, meaning that it has only magnitude. You don't know which direction it's going. Okay? If I wanted to show speed as a equation we could use for calculating, I could say that the average speed that an object is going is equal to its distance final, where it ends up, minus its distance initial, divided by the amount of time it takes for the object to travel that distance. Okay. Velocity, on the other hand, is the rate of change, in displacement over time. Displacement is a vector quantity, so velocity is also a vector, meaning that it has both magnitude and direction. Velocity has to be going in a specific direction. If I wanted to write velocity out as an equation, I would say that average velocity, and I'd put a hat on my v because vectors wear hats. Say average velocity is equal to displacement final minus displacement initial divided by time, the amount of time it took. Okay, so both speed and velocity, because it's some distance over time, can be expressed in units of distance over time. So either, for example, usually meters per second, which we can write as meters seconds to the minus 1, or kilograms, no, not kilograms, that's just being silly, kilometers per hour, which we would write as kilometers hours to the minus 1. Okay? So the IB exam likes to write things this way, so I think you should adopt this manner of writing things if you can. Okay, now to talk about acceleration. Acceleration is the measure of how quickly an object changes, acceleration is the measure of how quickly the velocity of an object changes over time. So, because it's the velocity changing over time, acceleration is a vector quantity also. Alright? And if I wanted to write an equation to show acceleration, I could say that average acceleration is equal to the velocity final minus the initial velocity that I started out as, divided by the time that that velocity changed over. Okay. Because acceleration is velocity over time, its units are some velocity over time. So the units of acceleration could be said to be some velocity, so meters per second every second, or we could say meters per second squared, or if we write it IB style, meters per second to the minus 2. Okay? This is something to keep your eye on when you're doing conversions of units. Make sure to square your conversions when you do conversions of acceleration, otherwise your units won't match up. Because this is okay. Last thing. So in this class, some of the numbers you're going to have are going to be positive and some are going to be negative based on which direction the object's going. And so it's just easier just to set it out ahead of time, and so we don't have to think about it later. So positive numbers will be numbers that if I drew x and y coordinates like I have here, would be positive. So a number going to the right of the y-axis, a number going up, a number going east, or a number going north would all be positive numbers. Negative numbers, on the other hand, would be numbers that show up as negative on the xy axis also. So a number going left would be negative. A number going down would be negative. A number going west would be negative. And a number going south would be negative.